A labor strike at Samsung is not just a temporary delay in the news cycle. It is a structural earthquake for the global artificial intelligence supply chain. You are clicking on this video because you need to understand why a strike halts AI progress in a way that software bugs or design flaws never could. By the end of this explanation, you will see exactly where the physical bottleneck lies and why no amount of code can fix a factory floor that has gone silent. To understand the stakes, you must first look past the headlines that treat semiconductor production like a standard manufacturing line. In most industries, if workers stop, machines keep running, or inventory buffers absorb the shock. In advanced semiconductor fabrication, specifically in the realm of AI accelerators, the human element is the machine. Samsung produces the advanced packaging required for the most powerful AI chips. This process involves heterogeneous integration, where multiple die are stacked and bonded together to create a single, ultra-dense processor. The critical step here is the die-to-wafer bonding and three-dimensional stacking. These operations require manual, high-precision handling that cannot be automated by software or accelerated by algorithms. Here is the thing that separates this from a typical supply chain issue. The failure point is not in the AI model design or the software stack that runs on the chip. The failure point is in the physical yield loss of heterogeneous integration. When the strike begins, the critical tune-up phase of wafer-level testing stops immediately. This is not a pause that can be resumed later with a simple software patch. The human expertise required to handle nanometer-scale substrates is the single point of failure for the entire global AI hardware pipeline. Consider the nature of the work being performed. Workers are manipulating substrates at scales where a single particle of dust can ruin a chip worth thousands of dollars. This is not assembly line work where a robot can take over if the humans step away. The process relies on the dexterity and judgment of skilled technicians who can detect minute anomalies in the bonding layers. Without them, the process halts. Because of this halt, high-value AI chips that are partially assembled face irreversible scrap. These chips cannot be reworked remotely. The physical assembly of the interconnect layers is frozen, and there is no virtual substitute available for this specific step. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This creates a zero-sum supply constraint. Unlike software deployment, where a bottleneck can be bypassed or scaled up by adding more cloud instances, the fabrication bottleneck creates a hard limit on the physical world. A strike immediately freezes the production of the specific interconnect layers required for next-generation AI inference. The industry cannot simply order more of these chips from a different location because the specific advanced packaging capabilities are concentrated in very few facilities. The lack of redundant, automated dark factories for this advanced packaging means that the strike exposes a critical fragility in the entire system. Now consider the timeline of the impact. In software development, if a team is blocked, the delay is measured in days or weeks of lost productivity. In advanced packaging, the delay is measured in the permanent loss of material value. Every day the strike lasts, millions of dollars worth of silicon and specialized substrates are rendered useless because the tuning process cannot be paused and resumed without compromising the integrity of the stack. This is a structural bottleneck that is distinct from software issues because it is rooted in the laws of physics and the limitations of current automation technology. The industry has spent decades trying to automate every possible step of chip manufacturing. They have built dark factories where lights are off and robots do the work. But for advanced packaging, the automation ceiling has not been reached. The complexity of aligning and bonding multiple dies at the nanometer scale still requires human hands. This means that the most critical engineering skills are no longer just about writing algorithms. They involve deep process integration and yield management. The physical assembly of AI chips is the true limiting factor for scaling AI capabilities. This insight changes how we view the entire ecosystem. When investors or engineers talk about supply chain risks, they often think of shipping delays or raw material shortages. This strike highlights a different kind of risk. It is the risk of human dependency in a system that has been optimized for speed and density, but not for redundancy in labor. The strike proves that the physical layer of AI infrastructure is more fragile than the digital layer. You can replicate a neural network model on 1,000 different servers, but you cannot replicate a specific advanced packaging run if the skilled workforce is not present to execute it. The implications for the future of AI are profound. If the industry cannot solve the automation gap for advanced packaging, then every future breakthrough in AI will be throttled by these physical constraints. The ability to scale AI depends on the ability to stack chips faster and more densely. If that stacking process relies on human labor that can be stopped by a strike, then the growth of AI is inherently unstable. This is not a problem that can be solved by better code or more efficient logistics software. It requires a fundamental rethinking of how we build the hardware that powers intelligence. The career-relevant insight here is clear. Engineers who focus solely on algorithms are missing the bigger picture. The most valuable skills in the coming decade will be those that bridge the gap between software design and physical manufacturing. Understanding yield management, process integration, and the specific constraints of advanced packaging will become as critical as understanding neural network architectures. The strike at Samsung is a wake-up call that the physical world still rules the digital one. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.